groups of atoms together. There are three main types of bonding: ionic, covalent, and metallic. In addition to these, there are also intermolecular forces, which are weak forces between molecules that are caused by Coulombic attraction between the positive end of one molecule and the negative end of another. Intramolecular bonding, on the other hand, are strong forces which occur within the compound or molecule. This is also based upon Coulombic attraction, but much stronger. This includes ionic, covalent, and metallic. Atoms bond together in order to achieve a lower energy state and to become stable. Ionic bonding involves the transfer of electrons between atoms to form ions. Ionic bonds are usually formed between metals and nonmetals. The metals lose electrons and the nonmetals gain electrons. Ionic bonds tend to be very strong, and the compounds formed are neutral. The Coulombic attraction between two atoms increases with increasing charge and decreasing distance between the charges. This means that the strongest ionic bonds are formed between atoms that are small and have high charges. Due to the strong nature of the ionic bonding, the compounds that are formed will have high melting points and boiling points. In addition to this, they will be poor conductors when solid because the ions are not free to move. They are, however, good conductors when in the liquid state or dissolved in a solvent. This is because when they are dissolved, the ions have the ability to move freely, whereas when they are in the solid form, they do not. Ionic bonding causes a giant 3D lattice to form. This is because cations and anions arrange themselves to maximize attraction and minimize repulsion. This rigidness that is created means that they are not malleable or ductile, and the bonds tend to be brittle. Finally, one of the last and possibly most important things to remember about ionic bonding is that while they normally occur between a metal and a nonmetal, that does not mean that all metal and nonmetal bonds are ionic. There are exceptions to the rule, and the only real way to check whether or not bond is ionic is to find the difference in electronegativity between the two atoms. If the difference between the two atoms is greater than or equal to 1.7, the bond is ionic. Next, we're going to talk about covalent bonding. Covalent bonding usually occurs between two nonmetals. The valence electrons of the two atoms are shared. The bonds can have dipoles, which means one end is positive and the other is negative. This means that the bond is polar. There are two types of covalent bonds: covalent network solids and molecular solids. Covalent network solids involve elements in group 14. This is because they can form 4 covalent bonds due to the ability to lose or gain electrons. These bonds are rigid with high melting points, and they form large continuous 2D or 3D networks. Examples of this would be graphite and diamond. The other type of covalent bonds are molecular solids, which include nonmetals, diatomics, or compounds formed from two nonmetals. They are made up of units only joined to each other by weak molecular forces. They do not conduct, and they have low melting points due to weak intermolecular forces. The final main type of bonding is metallic. Metallic bonding usually occurs in transition metals. Metal atoms arrange themselves into a lattice, which is held together by metallic bonding. This lattice is made up of positive ions surrounded by a sea of moving and delocalized electrons. Due to the fact that these are transition metals, which means that they have a lot of unpaired electrons, these electrons have the freedom to move throughout this sea. That freedom of electrons to move accounts for properties such as malleability, ductility, and conductivity. In conductivity, for example, substances can only conduct electricity if their ions have the freedom to move. This explains why ionic bonds can only conduct electricity in water, and covalent bonds cannot conduct at all. The freedom of electrons to move means that a current can easily flow through the substance. The malleability and ductility of the substances can be explained by the fact that the atoms can simply slide past one another, which is not true of the other kinds of bonding we have talked about. A quick thing to note when discussing bonding would be sigma and pi bonds. Sigma bonds are always the first bonds formed, and they are formed by an overlap of two s orbitals, an s and a p, or head-to-head p orbitals. Sigma bonds approach head-on as seen in single bonds. An example where we can see pi bonds would be ethane, which is C2H4. There is a double bond between the two carbons, so the first bond joins the two carbon sp2 orbitals head-to-head. And in the second bond, there is a sideways overlap between the other two sp2 orbitals, which is called a pi bond.